So I had the opportunity within the past year to head out to Berkeley University and attend long training in AI. And this is the kind of people that are there are the kind of people who walk into a VC meeting with an idea and walk out with a $500,000 check. They're also the type of people who Uber is recruiting at the salary of about $250,000 a year and having their PhD paid for at a top university in the world, which is why people in this room probably can't recruit them, okay? And so while I was there, I had the opportunity to talk to a lot of the speakers. And I always ask them one particular question. I asked them, what is the one secret that you don't tell on stage that everybody should probably know, but they don't know? And what surprised me was that almost everybody I spoke to had the same exact answer. Now, I want you to guess, take a guess at what that is. Lock it away in here, and we'll come back to it at the end of the talk. So what we're talking about today here is AI, the creation of intelligence. This is how I describe it, okay? And we're talking about artificial general intelligence. And this is the idea that we create intelligence where none existed before. Now, it may be difficult to see back there, but this is a worm that was taken bit by bit, computed all the neurons and how they fire in a worm and placed in a Lego Mindstorm and let run around. So for all intents and purposes, if you believe that worms have intelligence, which I do believe that, that's the definition I choose, then we've already crossed that threshold and have kind of become mini gods in a way. But probably what you're thinking of is more of this, which is the idea of a god placing life into something where there was none before, right? The book of Genesis, the idea of the breath of God breathing into a being. And various religions, everyone has a kind of a creation story that involves this kind of intelligence being imbued into some kind of substance. In a modern day myth, we have, of course, Frankenstein, right? This idea that we can create life using electricity. Now, this is what we're dreaming of. What are we dreaming of when it comes to AI? Well, some of the things people think about, sex bots, okay, which, let's face it, has driven most technological revolutions in human history, all right? And this is a fascinating topic, which I've actually spoken about before, purely from a scientific perspective, of course, but I'd be happy to discuss that more. We're also looking at elderly care robots. We're also looking at retail, or we're also looking at people working in factories, okay? All of these are embodied agents. So most often, people think about an embodied agent that looks kind of like a human. But what are we actually getting? What are we getting? Well, in the world of machine learning, we're getting recommender systems more often than not, which is great for us if we want to watch a movie and expand our taste a little bit. You probably used it, obviously, with Spotify, finding new music, which has been awesome, right? Or books, your recommended authors. But machine learning is essentially statistical analysis of things, and you're given some kind of result which you can apply to. Now, of course, there's some challenges with that. One of the things that you have here is you have all kinds of security challenges. I won't go over them too many because most of you know what those security challenges are. Something that came out back recently in 2016, it was found that Google, through the manipulation of its search results, manipulated about 1 million votes around the United States using machine learning techniques, okay? Now, there's a lot of question about how these all evolve. Who's involved? National security, you have the Chinese, you have the Russians. But we'll talk about that perhaps later. There is a subset of machine learning called deep learning. And this is where a lot of the large advances have come from. Unbelievable things. This right here is satellite imagery that has been used to determine crop yields. We can even see when things need to be weeded and send a process to start that. But this is where things like getting early cancer detections. We can now detect cancer better than a traditional doctor. So a radiologist can look at something and can scan more at once, right? They're more productive. And there's all kinds of chatbots and things. Whether those have been an asset to society is a question, up to a lot of people, but there's been a lot of great things that have come out of deep learning, and it's the hottest area right now. But of course, there's been challenges, right? A mass surveillance society. Are we ready for something like that? This is the Chinese system, which can find a face among all of its assets in less than 3 seconds, search 1 billion results and find a face and match it and track you. There are entire provinces, if you will, of states, similar idea, in China that are currently under 24/7 surveillance. Okay, and then we have meta-networks. Meta-networks. So these are where we combine different kinds of networks into one larger network. Many of you recognize Sophia here, who has been granted citizenship in Saudi Arabia, which is funny that she's gotten a lot more rights than women in Saudi Arabia. She's not even real, okay, in that nation. But the funny thing is that she is really not a true artificial intelligence. She's just a set of lookup tables and results. It's really what Sophia is. But these meta-networks are also things like the game of Go. You probably heard of the AlphaGo system that defeated the world Go champion, which people thought would have been impossible because there's trillions of potential moves. Okay, but there's a lot of stuff coming out of that, and some of the challenges. Well, a lot of the same technology, which is also going to self-driving cars, is going into autonomic weapon systems. Now, I'm not one of those people who believe that we should not be working on these kind of items. I understand the need for defense, especially at the nation-state level. I totally get it. The key aspect that you have to think about here, though, is where is the kill switch? Who is making the decision of what to do in this? If you take the human out of the loop, you've lost all opportunity for morality. Now, that's not to say that the military makes moral choices, because we know that's not the case all the time, okay? But there is a potential for abuse with these kind of systems. Now, why? Why are we running into these kind of things with AI? And so I'm going to take you down a little bit of a rabbit hole, all right? So let's see how well we do here. The question is, does life imitate art, or does art imitate life, right? That's the question. Are we becoming more digital because that's who we are? Is that the question? Or are we creating digital things, right? It reminds me of an old Marilyn Manson song that he used to sing, which was, I can tell you what they say from space, that our earth is too gray, but when the spirit is so digital, the body acts this way. So what does that mean? Well, let's take a look here. What are the challenges that we have with computer scientists and the questions that we ask? Is this idea of discrete quantization of existence. Okay, what does that mean? That essentially means that everything that transpires has to be quantified. Everything has to be put into a 0 or a 1, identified and logged, okay? And that's because the way we handle computer systems, designed back in the 40s with the transistors and everything, von Neumann architecture. Essentially, we have this little thing in it called a CPU. And all it is really a clock. And it's doing some computation. It has this uptick and a downtick, an uptick and a downtick, 0 and a 1. And that's how it manages the chaos that goes on within the computer, okay? Well, if you bring that into something like deep learning, we have this thing called the universal approximation theorem, which the entire field rests on. It's an axiom, which essentially says that if you have a function of something here and that you can map, you can replicate that in a neural network. And in many cases, you can do it very efficiently. But what the goal of that means is that everything that you do, every behavior that you have, everything that you are, is trying to be reduced to this, a function. It has to be reduced to a function. We have to quantify it in order to process it, compute it, and move on. Now, this sounds great because we have achieved a lot of great things with it. However, there are some challenges. So let's take a look at an example and why this might be a challenge. So this was done back in 2019. This was looking at hate speech. Twitter was looking at how to handle hate speech and how to automatically handle hate speech because there's just so much that's going on. There's just no way to watch it unless you're China and you have 10 million extra people that can sit there and watch the internet like the Great Wall of China and try to manage everything. We don't have the manpower to do that here. So the question is, how would this be handled? Well, what they found is that this actually targeted minorities at a rate of 2.2 times that of others. And why was that? Now, there's a lot of reasons why, and I don't want to get into them here about why I believe that is. I do want to touch base on one, though, because I think it illustrates the point most effectively. Okay? So, in this particular one of the things that they found was the use of the N-word by blacks in America. Now, we understand as a society what the rules of the engagement are on that, right? We understand that. That's called context, social context, and we understand that. But can a system like this understand that? Why? Well, the question we actually have to understand is, when is use of that word appropriate and not appropriate on Twitter? How would you be able to decide that on Twitter? So the question that's being asked to understand context, because remember, everything has to be quantified. We need a number. It has to be a number. The question they're asking, what is blackness? That's the question that has to be asked in order to assemble this. And it's an uncomfortable question for many because, okay, do we calculate by skin pigmentation? How much exactly? Okay? So if you normalize skin pigmentation on a grid and go from 0 to 1, okay, and what percentage exactly is blackness? Now I know somebody personally who is around 20% African and is white as snow. Okay? So the question is, do you do it by country of origin? Do you do like DNA testing? It's just, you're not going to be able to do this. And especially on a platform like Twitter that doesn't have visuals, how are you going to handle context of this nature? Is it cultural? Okay, well, what goes in a black-only category? How do you categorize that? Let's take a look at somebody who's cross-cultural. Michael Jackson started out huge, right? Massive, Jackson 5, right? Now, before Thriller, Thriller was what, 82? So you had him with the Jackson 5 throughout the 70s. Well then, at what point did Michael Jackson transcend what would be a black-only cultural category? Because remember, you have to quantify it. You need a number. You have to have a number. Everything has to have a number. Okay? So as you can see, this presents a real problem. When you're trying to figure out hate speech, you have to figure out context, social cues and context, quantify that. And to be honest, these conversations are being had in Silicon Valley right now by people who have no idea what they're doing. Okay. I got that on the recording, so it's perfect. All right, let's move on to the next challenge. If I brought this up, right? I'll make sure I got it on the camera, okay? Now, it always comes down to life is an issue of questions. Life is an issue of questions. And what the kind of questions that we ask determines what kind of answers we receive. And when we focus on those answers, that's what determines the fabric of our reality. It ultimately comes down to the questions you ask determine on a daily basis what kind of reality you experience. And so the question of here, if I was a computer scientist and I was looking at the experience of the spoon, I might be looking at, oh, well, it has contours. And I can calculate the contours of this spoon, and it has a certain reflection, which I can quantify at a 95% reflection, and I can do all kinds of things to create this spoon. If I was a hardware engineer, I might look at the color of it and say, it looks like it's silver. Well, I can melt the silver at this particular temperature, and I could do all these things and mold it. If I was a cognitive developmental psychologist, I might look at it and say, oh, it has a utility to it. What kind of utility does this have? And I would say, oh, I could eat with it, right? And do all those things. Whereas a parent might look at this and says, please, God, will my child please learn to eat with this thing at some point, right? Okay? And the philosopher will ultimately come down to the true realization, of course, which is there is no spoon, right? Now, it's about the questions we ask. People tend to start thinking very similarly when they ask the same questions on a daily basis together. And what we mean by this is a study out of Stanford back in 2016. This was looking at political donations by industry. Okay, and what we found here, and this is Adam, I'm probably going to mispronounce the name, Bonica, back in 2016, looked at donations. And if we look at these two particular areas, we have technology and oil and gas. Okay, now traditionally people think of oil and gas as a right-leaning, and it is the most right-aligned of these particular donations. And then over here you have your left-aligned occupations, which are academia, technology, and entertainment. And of course you can look at the donations. Now these were done by standard deviation. So if you look at these, I'm sure it's difficult to see from a distance, and I apologize. But the technology and academia are actually, by donation and standard deviation, are the most ideologically homogeneous groups out of all these surveyed. There's nothing in the middle. Now over here, you have in technology what I like to call the libertarians that they throw a bone to every once in a while, right? But essentially that's what you have. You have ideological homogeny. And over here, in a lot of these, you have more of a, what I call a middle group that kind of can be swayed and kind of keeps the edges from going crazy, right? But it's still even more right aligned than oil and gas, but you still have going up almost half the amount there. So you have this intellectual sameness because you have this intellectual sameness. I won't go into why, okay? I don't want to get into that conversation. What it means is that they're asking a lot of the same questions. They're approaching existence in a lot of the same ways, a lot of the computer scientists. And when we're dealing with the idea of intelligence, what it means to be an intelligent being, they're asking the same kinds of questions. And so there's this idea of simulacra and simulation. If you ever heard of somebody called Baudrillard, who was a philosopher in the 1980s, The Matrix was based originally on this idea of the simulacra and kind of went off into Plato world. But it's this idea that humanity will prefer the imaginary to the real over time. It's essentially what it means. We're going to create this illusion, and we're going to want to live in it and escape reality. And there's so much more to Baudrillard's argument. I know I'm not doing it justice, but this is kind of the idea. And in fact, it's so dominated the technology industry today that entire philosophical traits have come out where they believe all of life and existence is a simulation. I personally think the shots there's a possibility. It's certainly a possibility based upon a number of factors. But there's this idea of simulacra and simulation, and that's where the intelligence, what they're kind of building. They're looking to build a simulacra kind of intelligence. And so in a way, it's kind of like a false intelligence, where a replicant from Blade Runner, if you've ever seen those movies, a replicant from Blade Runner, maybe it's intelligent, or is it just simulating intelligence? They're focusing on the simulation, okay? But maybe a way to offset this is maybe to bring other people into the mix. Other people who have different ideas ask different kinds of questions. That's what you're looking for, different kinds of questions. So in this particular instance, I'm looking at depth psychologists because I think that they have the best notion of what a self is. And here you have Friedrich Nietzsche on the left. Carl Jung is perhaps probably the most intelligent person of the 20th century in terms of output and just their contribution to our understanding of what it means to exist. And what they came up with is this idea of the multiple layers of consciousness, right? We remember Freud and the subconscious and the unconscious. We take it for granted now so much that poor Freud, everyone, he's the joke, butt of so many cocaine jokes, right? About all the coke he did. But in reality, we've almost adopted as an axiom that there's this subconscious out there. And there's these multiple layers of consciousness, and how do they work? Well, if you apply that to something like artificial intelligence, you'd have like 1,000 minds theory. And so this is this idea that over evolutionary periods, different pieces of your brain kind of grew and kind of got stacked on one another. And this neocortex, the wrinkly thing inside your skull that wraps around your brain, it's called the neocortex. Really what it's doing is taking all those minds that you have and bringing order to it by making it vote on what it thinks reality is. And so I can look at here and I can see a computer, and 30% of my brain says, oh, that's a chair. 70% says, oh, that's a computer. And guess what wins? I see a computer, right? And so there's this idea of 1,000 minds theory. And if you can actually combine these, you can create these kind of meta-networks with threshold voting. This idea that we can experience time through this kind of voting mechanism. Another example, and this is one that I know I'm very excited about because I think this has a lot of potential, which is alchemy. I don't know if you're familiar with alchemy, but alchemy was this idea of the people can turn lead into gold, right? They spent lifetimes trying to turn lead into gold. But what Carl Jung found was that this description of turning lead into gold, while it was a physical process, more accurately described an inner psyche process, which represented, for instance, the turning of the lead, which is the shadow, the darkness within, into a unified person, a unified whole, acceptance of the shadow, creating this golden person, golden individual. And so there's a lot of representative ideas in the alchemy, in which, when he tied into things like the collective unconscious and some other ideas, really represent an interesting mapping of what it means to be a self, to be an individual. And so this is actually similar to how AI started with the computer scientists when they took it over back in the 1940s, 50s, and 60s, actually the 50s and 60s. Hinton and all those people out of Dartmouth, and they had this idea of symbolic representation, where they mapped different things out. And this symbol, this symbol, this symbol, and thought they could map them together to create meaning. It's kind of fallen out of fashion. But ironically, with new technology, we're starting to come back around to it a little bit. And this is this idea that we can take ideas of the subconscious and we can abstract them out into these other ways of layering architectures and computing architectures. Just some of the ideas that people have out there. Okay, so I was only supposed to go for a couple of minutes, so I'm out of time. Remember that thought, right? What were those people saying? Now, what those people said changed my life. Fundamentally changed my life. Changed my business, changed how I approach everything that I do. Okay? You know what the answer was? We have no idea what we're doing. We take a guess and we hope it works. And we only have a few small tools that work. That's it. That's what these people who are getting paid tons of money are doing. Okay? So that brings us to the unknown. Are we going to be like Alexander Fleming, who, in case you don't know, was working on a particular project back in the 20s, found some mold growing in a petri dish in the corner of his office, and boom, penicillin was made and saved half of humanity. Oh, that's awesome, great. Or are we going to end up more like Icarus, who, when trying to become like a god, fell to earth because his wax wings melted when he approached the sun? Which one are we going to be? I don't know, with the computer scientists. Let's roll the dice. So, thank you. Again, there's information about Suji, Lancaster AI. I always just want to note, all these opinions do not belong to any of my companies, my organizations, or any of my clients. They are mine and mine only. All right, thank you. Have a good night.